This is the second video that goes with equivalent ratios, lesson 4.2 from our 6th grade Math and Focus textbook. So I've just turned your worksheet, your extra practice, lesson 4.2 over, and these are those word problems that we didn't tackle the first night, but we're going to look at today. So if you take a look, it says we need to solve. Well, this is kind of interesting because they're giving me another way to look at ratio in a table format. So for number 19, it says the ratio of the length to the height of the American flag is 3:2. Complete the table. Well, what's really nice about this is they already filled out the length, which they said is 3, and the height, which they say is 2. It's kind of like having the first term of a ratio and the second term of a ratio. Well, next is kind of like finding the missing piece or the missing term of a ratio. So if you look, it's hard for me to go from 3 to an empty or unknown box. But I could quickly go from 2 to 24 following some rule of equivalence. So I want to figure out what are they doing to get from 2 to 24. Well, if the number is growing, I know I'm multiplying. What would you multiply by 2 to get to 24? Hopefully you'd say times 12. And if I do that to the second term or to the height, I'd also have to do the same thing to the length. It's kind of like if you are taking a picture out of Google, you're copying and pasting it. If you drag from the corner, you can enlarge that picture by length and height. But if you accidentally just grab the side, you're going to distort the picture. It wouldn't stay the same dimensions in a larger size. So we want to keep it the same. We want to use the same rule here. 3 times 12 is actually 36. Oh, we found the missing piece. We want to go again, but if you notice in the next column, they give me the length, but not the height. So they're really telling me, well, go back to the original length of 3. How would I go from 3 to 60? If I can figure out this rule in a minute, I'll be able to fix the height and go from 2 and figure out the unknown dimension. Well, in this case, I know 3 goes into 60 20 times. And it looks like I'm multiplying. The number's getting bigger, so I'm going to say 3 times 20 will get me 60. If that's true, I do the same thing with the second term. I take the height of 2 and I multiply by 20. Well, 20 plus 20 is actually 40, so we just found the missing term of our ratio, or the missing piece. All right, we want to try this again, but if you notice, this is getting a little bit complex because, again, I don't know the length, but this time I know the height. So we want to go back to the original height, this original height of 2, this ratio that they originally gave me, and figure out how do they go from 2 to 52. Well, I hope you realize that they're multiplying by something, and I could figure out that unknown rule if I figured out how many 2's go into 52. Well, what's half of 50? Hopefully you'd say 25. What's half of 2? 1 more. So 25 plus 1 more. They must be multiplying by 26. Oh, I can see that in my mind. 26 plus 26 is 52. If that happens to the second term or to the height of this flag, it also has to happen to the first term or the length of the flag. So I'm going to multiply by 26 again. Well, this actually means 3 times 26, doesn't it? So the original length times 26. 3 times 20 is 60, and 3 times 6 is 18 more. Let's see, 60 plus 18, looks like I'll get 78. I hope that as you look on here to the next step, you notice that they give me a length, which again lines up with the first term. And what I don't know is the second term. So the length is going to help me determine the rule. I'm going to go from 3 to 96 using some rule. And I notice that this flag is getting larger, so they must be multiplying. They're using a rule of multiplication. Once you figure out how many 3's go into 96, figure out what they're going to multiply by, we'll be able to do the same idea or use the same rule to complete the missing term. So 2 times something in a moment, the same rule, remember, that we're going to find, will help me get to the unknown term. Another way to think about this, you could take 96 and divide by 3 to figure out what your rule might be. Or you could try number bonds. We could turn 96 into, how about 30 plus 30 plus 30 plus 6 more? I did that because I noticed 30's divide nicely by 3's, don't they? Just food for thought. I'm not going to finish this last piece for you. I'm just going to let you think about that for part A. See if you can fill out that last piece. I already got you started. So again, first consider the rule where we know both terms, and then apply that rule when we only know one of the terms. Next, we want to take a look at part B. And this one's kind of challenging because they're kind of relying on our decimal knowledge from the last unit. And notice that they say that we want to make an American flag that has a length, oh, that was like the first term here, a length of 1 8/10 yards. Now we have to find its height. Well, what they're really saying is, I'm starting with a ratio of 3 to 2. That came from the original ratio in my table. And I want to turn this ratio into a length of 1 8/10 to, gosh, I don't know. I have to fill out this missing piece. So if you notice, we probably could quickly find a rule. I know that 3 times something gets me 18. Well, 3 times what? 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6. 3 times 6 would get me 18. The problem is I wouldn't have that decimal, would it? But it'll at least get me going in the right direction. Let me think about this. 3 times 6 is 18. What would it take to move that decimal over one place? How would I change my rule of multiplying by 6 to turn this into one decimal jump? Or how would I get it to count a total of one jump? I think that's what we're trying to say here. So that 3, it's given to me. It's a whole number. There are no jumps in the bank, no decimal places to save. But what about the 6? I want to make one jump total, so I think I'm going to have to count over one spot. Somehow I have to get a decimal in front of it, which will require me to jump one hop, or take one hop in my final answer. This can't be times 6, but it could be times 6/10. Then the decimal bank would land in the right spot. I like it. If that's true on the other side, I'm not just going to multiply by 6, although that would be a great start, because I know 6 times 2 is 12. I know I'm going to get the numbers of a 1 and a 2. But remember, I'm not multiplying by the whole number 6. I'm multiplying by 6/10. So over here, I'll change this to 6/10 in my work. And what will that do if I build a decimal bank? Oh, there's one jump plus no jumps makes a total of one hop, or one jump. This won't be 12, but it would be 1 2/10. I just found the height. So they asked me in a word problem to find its height, or the height of this flag. So I think I would have to say 1.2 what? What are they measuring in here? Well, this problem talks about yards, so here we're going to call it yards. 1 2/10 yards. That's the height of our flag. We're going to take a look at a couple more word problems here, and notice that there are some conversions, and I told you in a previous lesson, it's not required that you're a master of this. You won't actually be tested over these pieces, but I do want you to be somewhat familiar so that it doesn't scare you too much. Let's see if I can get this to kind of sit where we need it. All right, number 20. Nicole uses 5 ounces of mushrooms, 2 ounces of butter, and 1/4 a pint of cream to make mushroom soup. Easy for me to say. I haven't eaten dinner yet today. All right, so on number 20, I noticed something. What I really like is that I have ounces of mushrooms. That's awesome. And I also have ounces of butter. That's pretty cool. The problem that I have here is I have pints. And if you remember, pints and ounces aren't the same size units. Well, we did something like this on the previous side of this worksheet. You remember how I showed you in our gallon man, or maybe in our mnemonic device, that if you drew a P for pints, inside I'd find 2 cups. And inside each cup you'd find 8 little ounces. So the question is, how could I change this larger unit of pints into ounces? Well, I know in 1 pint there are 16 ounces. 8 plus 8 is 16, or 8 times 2 is 16, right? But I only want 1/4 of that. Can you picture for a quick minute? It's like saying I have 16 ounces altogether, and I only want 1/4 of that. 1/4. Well, how much is that? Well, it's like taking this 16 and dividing by 1, 2, 3, 4 units. Well, how many go in each? Well, there would have to be 16 divided by 4. 4 in each. 4 here, 4 here, 4 here, and even 4, oops, I guess I probably could have put it right inside the box, but 4 here. So another way of writing this 1/4 of a pint is to change it and call this 4 ounces. Oh good, finally we have all the same size units. Looks like I'm ready to do some comparing. So I didn't even read the questions. I just noticed I was going to have a problem with my units. Make them the same before you do anything else. For part A, we want to find the ratio of the number of ounces of mushrooms to the number of ounces of butter to the number of ounces of cream. Oh, mushrooms to butter to cream. I'm going to write that. Mushrooms to butter to cream. If you want to actually write out the words, it's going to take you a while. So I'm okay with this idea of using kind of the first letter to kind of help us out and use a quick shorthand so I can make sure I have the right organization. Well, go back to the beginning. How many ounces do we have for our mushrooms? What was the measurement for mushrooms? 5. What was the measurement for butter? I'll go back to the beginning. There's butter, 2 ounces. And what was the measurement for cream? Remember, they asked for this in ounces this time, so I'm not going to use the 1/4 of a pint. I'm going to write 4 ounces. Can I simplify this ratio? It's a 3-term ratio today because they said 2 twice. They said compare this to that to that. Well, I'd have to divide them all by the same common factor. And because I can't do that for this problem for part A, this is a final answer. It's in simplest form. Take a look at part B. It says Nicole's going to use 15 ounces of mushrooms. How many pints of cream does she use? Well, now they're getting tricky on us. So let's take our original ratio. If you notice, the original ratio of mushrooms to pints of cream is what I'll list first. So mushrooms to cream. And this is tricky because, again, they wanted me to use pints this time. Try to get us to think, I guess. Catch them in their complex questions. So how many ounces of mushrooms do you see? 5. And how many pints, this is weird, how many pints did they use of cream? 1/4. 1/4. And I might label that pints, and I might label this ounces. Oops, didn't save myself much room, but we'll smush it in there for today. Okay? They're changing the recipe. Sounds like she's making more, because I noticed something. She went from just 5 little ounces of mushrooms to 15 ounces of mushrooms. So that means that I'm going to need to use more cream if I want to keep the recipe still tasty. So how did you go from 5 to 15? Well, you really multiplied by 3. And if you do that to one term, you must do that to the other. Oh, we get to multiply a fraction. Off to the side, I'm going to think about what is 1/4 times 3. Oh, 3 could look like a fraction, like 3/1. There's no cross simplifying, even though I'm looking. I get to multiply straight across my numerators. 1 times 3 is 3, and 4 times 1 is 4. Looks like I'm going to get an answer of 3/4. It's going to take more cream, 3/4 of a pint of cream. Well, this is actually a word problem, so I better give them some words back. The missing piece I was looking for here was this. So I'm going to write 3/4 pints of cream. Final answer. Now again, this was pretty complex because some days I turn everything into the same size units, and some days they go, let's do something different. Let's try it with pints instead. Let's look at part C. I'm going to clear myself some room, so I hope you're caught up here. It's going to disappear quickly. We can always press rewind if you're in YouTube, right? All right, part C. It says if Nicole uses 1 pint of cream, how many ounces of butter does she use? Oh, look, we're starting with cream, and they're back to using those pints. All right, and then the question is, how much butter? Ounces of butter is what I'm comparing it to. So the first thing I want to see is cream to butter. And the cream came in 1/4 of a pint, and the butter came in ounces, like they said here. And if I go back to the beginning, oh, right there, I see that there are 2 ounces of butter. I want to make an equivalent ratio. I want the recipe to still taste delicious, although I don't care for mushrooms. All right. So the question is, how do I go from 1/4 of a pint to 1 whole pint? And then what would it take? How many ounces of butter would I need over here? This is the unknown piece, what I'm trying to find. Well, I hope you can think of a number that times 1/4 would get me to 1. I'm trying to figure out the rule here. Or you're saying, how many fourths does it take to get back to 1? Well, I can picture this real quickly. If I had a bar split into 4 parts, here's 1/4, 2/4, 3/4, 4/4. Oh, 4/4 is the same as 1 whole. So how many fourths did it take? It took 4 of them. I really need to multiply this by 4. And if I do that to the first term, I do that to the second term. So what is 2 times 4? It's 8. And again, they're measuring in ounces. Well, this is a word problem, so I better give you a final answer in word form. It's going to require 8 ounces of butter. Would it be better to put this in an awesome sentence that talks about Nicole and her recipe? Probably. Would it be awesome to start your sentence with the word form of a number? Probably. But this is a good start for today. The last thing we need to look at is number 21. Asha's making some smoothies. Yum. I could go for one of those right now. All right. For this final question, I notice we're going to have some units to work with, and I wonder if they're all the same. Let's find out. Asha mixes 50 milliliters of yogurt. I'm going to do some color coding here. 50 milliliters of yogurt. 100 milliliters of orange juice. Probably should have made that orange. And 250 milliliters, oops, I already used purple, try something different. 250 milliliters of milk to make a regular smoothie. All right. It says, what is the ratio of the amount of yogurt, yogurt, to the amount of orange juice to the amount of milk? I tried my coding strategy in this sentence, or this actual question. I haven't really done that before. I kind of like it. I noticed that yogurt came first, orange juice came next, and last they asked for milk. So let's go ahead and write these out in order. If they say yogurt first, I go and find the first measurement for yogurt, 50 milliliters. Oh, these are all milliliters. I might be good to go. Orange juice, how much orange juice did it take? Oh, right up here I see 100 milliliters of orange juice. This is the metric system, so I don't usually measure like this in the kitchen. But maybe if we traveled overseas, you would. Or maybe just to Canada. Next it says how much milk. So go back to the question, or I'm sorry, the sentence. The ingredients where it says 250 milliliters. They're asking me for a ratio. They're not actually asking me for how much of each ingredient. So do you notice something? All of these end in zeros. That really means that I could divide each of these by, say, 10. Oh, 10 will go into each of these. Let's see what I get. 10 goes into 55 times. 10 goes into 110 times. And 10 goes into 250 25 times. I can picture it. Oh, I'm still not in simplest form. So even though I was given really humongous numbers, I know I can divide another time. I know I can simplify this ratio as long as I use the same rule for all the terms. Well, what goes into 5, 10, and 25? 5, of course. How many 5s go into 5? Just 1. How many 5s go into 10? Just 2. How many 5s go into 25? 5. 1 is as low as we can go with our ratio or our fraction, so in this case, it looks like we have a simplified form. Part B, Asha's going to use 1 liter of milk. Oh my gosh, Asha, why are you going to change units on us? She's going to use 1 liter of milk, it says. How many regular smoothies can she make? So 1 liter of milk. This is different. Up here we've been talking about milliliters, milliliters, milliliters. So you might go to your metric chart and you might do some looking. You would find that 1 liter is the same as 1,000 milliliters. You also might think of this word milli, like a millennium. Oh, we're talking about several years, like 1,000 of them. There's another way to get there. I know that in science class, Mr. Joslin used to teach this. He hasn't seen this with you yet this year, but it's not bad to put this kind of in your memory. Sometimes I say King Henry doesn't usually drink chocolate milk. And the idea behind this is a mnemonic device, meaning it's just a memory strategy to help you understand the metric system. So these actually stand for different units in the metric system. The one that we really care about right now is the units. Units in this case are measuring liters. So I'm going to put 1 liter here with a decimal behind it. A whole number always has a decimal behind it. And now if you were to read after the liters, we'd get to deciliters, centiliters, and milliliters. How many jumps or hops would it take? This is kind of like our decimal movement that we play in Simon Says, or when we're dividing or multiplying decimals. It would take 1, 2, 3 hops. So I could fill in 1, 2, 3 zeros. Oh my gosh, I can actually see in my chart that 1 liter, started out with 1 liter here, is the same as 1,000 milliliters. So I kind of get to stop in that milliliter column and fill in those placeholders, and I can see the conversion in another way, without having to memorize it necessarily. All right, so if that's true, instead of writing 1 liter, I might instead write 1,000 milliliters. I might change that a little bit, okay? I might make that a little more meaningful. So the question is, if I started out with an original quantity of milk, let's look. I have milk here and it says 250 milliliters. And it doesn't really give me a ratio as much as it tells me to change the 250 milliliters to 1 whole liter or 1,000 milliliters. The question is, how would you get there? If you ignored those zeros for a quick minute, maybe at the back, do you see how it would be like saying 25 times something would get you to 100? Oh, okay. Well, what times 25 gets me to 100? I hope you're thinking money. 25, 50, 75, 100. Looks like there will be 4 groups. Oh my gosh, that's actually an answer. If I took 250 times 4, I would get to 1,000. It looks like it checks out. It looks like Asha can make 4 regular size smoothies. So I'm trying to give words back. Give a label when you can, especially in a word problem. This last one talks about Asha wanting to make regular smoothies for herself, her 2 friends, and a small smoothie that is half the size of a regular smoothie for her younger brother. That's nice. I'm not sure my siblings would do, or my kids would do that at home for their siblings. Well, anyway, it says how much yogurt, orange juice, and milk will she need? Well, this one's interesting because if you notice, you kind of have to read carefully here to figure out how many smoothies we're talking about. Asha's going to make a regular smoothie for herself. Oh, that's 1. And her 2 friends. Oh, that's 2 more. So 1 plus 2. How many regular smoothies are we talking about? Looks like she's going to make 3 regular smoothies. It's supposed to say regular, but we'll make it work. Take a look at this. She's also going to make a small smoothie. It says a small smoothie. That really means 1 small smoothie that is half size. This is important. Her brother gets something smaller because he's younger, I guess. Well, let's see what we can do with that. It's kind of like saying I want to make 3 regular and 1 half. Oh, 1 half smoothie. Oops, how do you write smoothie if it's just one of them? I guess like this. Okay. So if I were to combine these, how many smoothies am I trying to make? 3 and a half. All right, they want to know how much we need to use. So if I go back to the question, it says how much yogurt, that comes first. How much orange juice, that comes second in my ratio. How much milk, that's the 3rd ingredient and the 3rd comparison in my ratio, will she need? Well, I think we should probably go back to our original measures. So how much yogurt did it take at first? Well, 50 milliliters. We need 50 milliliters for just 1 smoothie. How much orange juice? Oh, I see it right here. 100 milliliters of orange juice. And how much milk? Oh, right over here. 250 milliliters of milk. Think about this. How many smoothies is this representing? These ingredients are just 1 smoothie. Do you remember that she wants to make 3 and a half of them? 3 and a half. It's like taking each of these measures times 3 and a half. This times 3 and a half. This times 3 and a half. And this times 3 and a half. Before you start panicking because you see a mixed number, I hope you can go back to something that we saw in the past. Our previous unit of study would say, well, we can take any mixed number and multiply as long as we turn it into an improper fraction. Oh, 2 times 3 is 6, plus 1 more gets me 7. That's the same as 7 halves. Oh yeah, 3 bars split into 2 parts gets me 6 halves, plus 1 more, 7 halves, times 50. I wish that 50 looked like a fraction. Oh, now it does. Right, it is 50 over 1. You might notice that you can cross simplify here. So 2 and 50 both divide by 2. Half of 50 is 25. Think money. And half of 2 is 1. Let's multiply across. 7 quarters, or 7 times 25. Well, 25, 50, 75, 100. And we have some extras, right? 3 extras. So 125, 150, 175 over 1. That's really the same as 175. It's going to take her 175 milliliters of the yogurt. I need to do the same thing with the next 2 ingredients. I need to figure out how much orange juice and how much milk she's going to use. So use the same strategy. Try to multiply, add, and keep. Turn that mixed number of 3 and 1/2 into 7 halves and multiply by the ingredients that we were given. See if you can figure out how much of each ingredient she needs. I do want to remind you that when you're done, this is a word problem, and I'm really running out of space, so I would imagine you are too. Line paper would be an awesome idea, although I don't know how to do that on my Promethean. So when you're done, I hope that you don't simplify. I hope that you actually tell me how much it's going to take for her to make those 3.5 smoothies. I might start by saying it will take blank milliliters of, remember we're talking about yogurt, comma, blank milliliters of orange juice, and blank milliliters of milk to make, what is she making today? Smoothies. How many? 3.5 smoothies. Ooh, even better, you could tell me it will take Asha. Just added a detail. You get the idea. I hope that you're able to finish those last two on your own. Again, you're going to have to do something about those 3.5 smoothies. You're going to have to take that 3.5, turn it into an improper fraction before you multiply by your ingredients. All right, I hope that you're enjoying this ratio idea. I hope that you're finding it challenging, but also kind of exciting that you can handle such complex problems. So try to finish those on your own today before we turn this in, and move on to some more real-world problems with ratio in our next lesson. Oops, you can't shut off the video if you're tapping on a pen.